starting differentiation. So let's start with the formulas that you need to know. So these formulas are very, very important and you need to apply them whenever you're answering any question concerning differentiation. So we have the power law. So how can you apply the power law? So usually the power law applies when you have a question in this form where you're going to have x to the power n. So in this case, n is the power. So when you're differentiating, you're finding dy dx. So when finding dy dx, using the power law, you need to multiply the power, multiply by the base. So in this case, the base is x there. And then what is going to happen to the power is that the power is going to be reduced by 1. So you always need to less by 1. So this is the formula. An example. Let's say you have been given y being equal to 2x to the power 3. You're finding dy dx. So here, this power is going to multiply with the base. So it is 3 multiplied by 2x to the power 3, then minus 1. So what are we going to have? We are going to have 6x to the power 2. Since 3 minus 1 is 2. So this is our final answer for dy dx using the power law. Now what about the constant law? So when it comes to the constant law, we are talking about a constant number. What is going to be the dy dx of a constant number? So what is the dy dx of a constant number is 0. So when you have y being equal to 2 or any number, whenever then that thing that you have been given is a constant, meaning to say the dy dx is going to be equal to 0. So the dy dx of a constant number is 0. Now what about the constant multiple? So this is number 3. So here we're looking at the constant multiple. This one is L. The multiple law. How do you handle this kind of equation? So let's say, for example, you have y being equal to c, then f of x. So f of x is a function, then c is a constant in this case. That's the reason why it's called constant multiple law. So in this case, just going to give an example. Let's say we have been given something like, let me just use f of x. Let's say we have f of x being equal to, let's say 2, then open bracket. Then we have a function g. Okay, so now let's say this g function g of x, let's say 3x squared. It is 3x squared. So how are we going to find this one? So to find the dy dx of this one, what are we going to do? We're going to find the dy dx of this one and then multiply and then find again the dy dx of that. But in this case, to make it easier, let me just give you this one. Let's say we have 2, then f of x is that. So how can you go about this one? So when you have this kind of equation where f of x is equal to this, how can you go about this one? So the first thing, you need to find the dy dx of this. So what is the dy dx? So the first thing, we're going to use the power law where we're going to multiply this with that. Then what are we going to get? We're going to get 6, then 2 minus 1, which is just 1. Then when I multiply here, 2 multiplied by 6, I'm going to get 12x. So meaning to say this is going to be our final answer. So this one is called the constant multiple law. Now what about this one? How can you answer this one? Let's say you have been given y is equal to 3x squared plus 2x plus 5. How can you go about this one? And which law are we going to apply here? So we are going to apply the power law. So we are finding the dy dx. We are going to use the power law. So 2 multiplied by 3, that is 6. and then the same 2 minus 1, that is x. Then here we have a power of 1, so it's 1 multiplied by 2, which is just 2. Okay, so which is just 2. Because we know to say that 1 minus 1 is 0, and then number raised to the power 0, it is 1. So 1 multiplied by 2 is 2. Then the constant number, if you remember, using the constant rule, the dx of a constant number is 0. So that's the reason why we are having a 0 here. So we just need to erase that one. So this is our final answer. So that is how we are supposed to answer that. Now, there is also another rule that you need to understand. Different functions once we find the differentiation. Okay, so we're looking at the sum rule. So let's say, for example, you have f of x as a function as well as the g of x as a function. So how can you find the dx of this one when you're adding f of x plus f g of x? So what is the formula? So the formula is just very simple. Here we are finding dy dx. So dy dx is going to be equal to df dx plus dg over dx. So we are adding the differentiation of these two. Okay, well, in short, you need to find the differentiation of this one, you also find the differentiation of this one, and then you add. So this is the formula that you need to use. Okay, so let me just give you an example. Let's say we have f of x being equal to 6x to the power 2 plus 2x. Okay, then also have g of x. Let's say this one is equal to 4x to the power 3 plus 3x to the power 2. So these are the functions that we have. Now we want to use this formula to find the sum using the sum rule. So what are we going to do? So we are finding y being equal to f of x plus g of x in terms of the differentiation. So what are we going to do? Dy dx is going to be equal to the differential of f. So what is the differential of f? So differential of f, we have df dx. df dx, we have 2 multiplied by 6 x to the power 2 minus 1, then plus 2x 1 minus 1. So this is what we have for df dx. What about dg dx? What do we have? dg dx, we have 3 multiplied by 4, then x to the power 3 minus 1. We also have 2 multiplied by 3, then x 2 minus 1. So this is what we have. So what is going to be the outcome here? 2 multiplied by 6, that is 12. Then 2 minus 1, that is just 1. So we are going to have a single x. And then 1 minus 1, that is 0. And number raised to the power 0 is 1. 1 multiplied by 2 is 2. Then plus. Then on this part we have 12 there also. X to the power 2. Then on that part we have plus 6x. So this is what we have. So you can see that these are like terms, so they can be added together. So let me start with the number of the highest power. So 12x to the power 2. Then plus this one plus that, that is 18x. Then plus 2. So this is going to be our final answer. So that is how you are supposed to use the sum rule. Okay. Let's see also other rules that you need to know here. So these are very, very important to know. You just need to keep them in mind. So the next one is going to be the difference rule. The difference rule is similar to the sum rule. Now the only difference is that here you are dealing with the minus. So difference law. Here you are dealing with a minus. So if you have y being equal to f of x minus g of x. So similarly, if you have f of x being equal to, let me just make it simple for this part. Let's say we have this, and then for g of x, we have, let's say, 2x to the power 2, then plus 2x plus 1. Let's say we have this one here, and then we are finding the difference, the dy dx using the difference law. So dy dx is going to be equal to df dx minus dg dx. So what is our df dx? df dx is going to be 12x squared. Where is this one coming from? We multiply to 3 multiplied by 4, then you raise the power by 1, going to get this, then minus open bracket. Once we find the dy dx of this one, what are we going to have? We're going to have 4x plus 2. This is what we are going to have, and then we multiply x, or let me say negative throughout. So we are going to have 12x squared minus 4x minus 2. So this is going to be our final answer. So that is how we are supposed to apply the difference law. What we are going to look at is the chain law. So you need to know how to use chain law and when you're supposed to apply it. So let's say, for example, if you have been given a function y being equal to f open bracket g of x and then close square bracket. So in this case, it's more like we have two functions. An example of a question where you're supposed to apply chain law is this one: y being equal to open bracket 2x plus 3 then to the power 4. So this is an example. Now which formula are you supposed to use? So in this case, you need to use this formula. So dy dx has to be equal to dy du then multiplied by du dx. So in this case, if you see clearly here, these, they can cancel each other. And then you're going to remain with dy dx. So dy dx is equal to dy dx. So that is where that one is coming from. So now let's see where this du and dy du and du dx is coming from. So we have this question. Okay. So for this question, you need to come up with two functions. Okay. You need to come up with two functions. So how? We are going to let what is inside here being equal to u. So if we let what is inside there being equal to u, so let u being equal to 2x plus 3. So if we let what is inside being equal to u, what is going to be y? Y is going to be equal to, now y is going to be equal to, in the place of what we have inside here, I'm going to put u then to the power 4. This is what we have. So we need to find the dy dx of these according to what we have. So let me start with this. So we are finding y with respect to u. So it is going to be dy du, and this one is going to be equal to, so the power is multiplying with the coefficient, so the coefficient here is 1, so we have 4 u to the power, so we have 4 minus 1, which is 3. So we have found our du. Let me say dy du. What about u with respect to x? So du over dx, this one is going to be equal to, so here we have 1, 1 multiplied by the coefficient there, we are going to get 2. Then 1 minus 1, that is 0. So the dy dx of a constant number is 0. So this is our du dx. That is what we have. So let's replace. We are finding dy dx. And this is equal to dy du. What is our dy du? Dy du is 4 u to the power 3. Then multiply by du dx, which is 2. Okay, so when I multiply 2 multiplied by 4, that is 8. And what is our u? Remember, u is equal to 2x plus 3. So 2x plus 3, then to the power 3. So which means this is how you're supposed to answer this question. Me is that one. So this is how you're supposed to answer that question. Okay. So let's see the next question, or the next rule that you need to know. So we have the product rule. So product rule. So when do you apply product rule? So let me also give you one question to try. Under chain rule. So let's say you have y being equal to 4, open bracket, you have x, the power 2 plus 1, then this is equal to 100. You can also try to answer this. Now let's focus on product rule. What is product rule and when do you apply product rule? Product rule is applicable when you are multiplying two functions. So this one can be y being equal to, let's say v of x, then let me say a v of x and u of x. You are multiplying two functions. Then you want to find the dy dx of two functions that you are multiplying. Which formula are you supposed to use? So you need to use this formula. Dy dx is going to be equal to v du over dx plus u dv over dx. So this is the formula that you're supposed to use. Very simple to use. So let's see an example. So in this one, I'm going to give you an example concerning the trigonometric functions, the differentiation of trigonometric functions. So let's say you have y being equal to x to the power 2, then sine x. So for this question, we have two functions. So we can label our functions using these letters that we have, v and y. Let me say v and u. Remember, this one can be also be written as u of x multiplied by v of x if you want. So meaning to say, if we say u is equal to x squared, then v is going to be equal to sine x. So these are the two functions that we have. So we can easily find now the differentiation of these or these. So let me start with this one, which is u. So we are finding du dx. Du dx, this is equal to, let me erase this one. Okay, like that. So du dx is going to be equal to, so here what we have x to the power 2, and this one can be written as 2x. When you multiply 2 multiplied by 1, then 2 minus 1, you're going to have this. What about this one? We are finding dv over dx, and this one is going to be equal to, so the differentiation of sine x is cos x. That is one thing that you need to understand here. The differentiation of sine x, it is cos x. So let's apply using this formula. We are finding dy dx, and this is equal to, what is our v? So we have v here, and v is sine x. What about du dx. du dx, what do we have there? Du dx is this one, which is 2x. What about u? So our u is x squared. What about dv dx? dv dx is cos x. So this is what we have. So we can just rewrite that in order. So we are going to have 2x sine x, then plus x squared cos x. So here we can rearrange the terms in order, starting with the one which is having the highest power. So we have x squared cos x, then plus 2x sine x. So meaning to say, this is our final answer using product rule. So using numbers, let's say we have two functions. Let's say we have f of x being equal to 2x squared plus 4x. Then let's say g of x is equal to, let's say, okay, yeah, let's say we have this. Then let's say we have 3x squared. Now we want to find the dy dx of f of g. Okay, then multiply by, let me say f of x and d multiplied by f of g. We are finding this one, which is the dy dx of this one. How can we go about that? So very simple. Using that formula, we can say let u being equal to 2x squared plus 4x and v being equal to 3x squared. So what are we going to have? Using this formula, dy dx, which is equal to v du dx plus u dv dx. So let's find du dx. So for this part, du dx is going to be equal to, so we have 4x plus 4. What about dv dx? This one is going to be equal to 6x. So it's just very simple. So what do we have on this part? Our v is 3x squared. What about du dx? Du dx, we have 4x plus 4, then plus our u is 2x squared plus 4x. Then what is our dv dx? dv dx is 6x. So what are we going to have? Here I'm going to multiply. So we have 12x to the power 3 plus 12x to the power 2, then plus. So this 6 here, x is going to multiply everything here throughout. So it's more like we have the open bracket and close bracket. So we have 12x to the power 3. We also have, since this one is 4x, we are going to have 24x squared. So these they can be added, and also these they can be added. So what are we going to have? We are going to have 24x to the power 3, then plus, so 12 plus 24, that is 36, then x to the power 2. Then from there, we are done. So that is how you're supposed to apply the product law. Then the second one is going to be the quotient law. So you need to know when to apply product law, when to apply chain law, and when to apply the quotient law. So the quotient law focuses on the division of the functions. Okay. So you have the quotient law. So let's say we have y being equal to u of x and then divided by v of x. So as you can see here, we have two functions which are being divided. This one can also be equal to f of x divided by g of x, depending on the functions that I have given you. Right, so how can you go about this one? So what we are going to do here is this. The formula for finding the dy dx using quotient rule, let me start with this one and then end with this one. So this one is the denominator and this one is the numerator. So this one why I'm emphasizing on you knowing the denominator and the numerator. There is a nice part that you need to know, and that one you are not supposed to forget about it. So you need to multiply v du dx, then minus u dv dx, and this one is going to be divided by v squared. So this is the first formula that you need to know when you let the function that they are going to give you being equal to v and u and v. But let's say, for example, if you just want to go direct when you have been given the function f of x and g of x, what are you supposed to do? So the first thing, you need to find f prime. So when I say f prime, you need to find the dy dx of f, then you multiply by the g function, and then you need to less. Then here for the second part, you need to find the g function. Let me say the prime of g function, then multiply with the f function, then divided by g of x, and then you square this part here. So this one and this, they are just the same, so whichever way you like. So let me just give you an example. So let's say we have y being equal to x to the power 2, then divided by x plus 1. You want to find the dy dx of this one, so which you are going to use? We are going to use the quotient rule. Okay, so here you can let whichever way you like. If you want to select this one being equal to u or this one being equal to f, it is just the same. So if we let that one f of x being equal to x squared and g of x being equal to x plus 1, meaning we are going to use this one, or you can say this one being equal to u and v being equal to x plus 1. And let's see what we are going to have. Okay, so let me start with this one. So what is our du dx? So this one is just going to give me 2x, and then in dv dx is just going to give me 1, because you know to say that here we have 1, so 1 multiplied by 1 is 1, then 1 minus 1, that is 0, and then n number equal 0 is 1, 1 multiplied by 1 is 1. The dy dx of the constant number is 0, so this is what we are going to have. So let's apply using this one. So what is our v? Our v, it is x plus 1. Then what is our dv dx? dv dx is 2x, then minus, what is our u? Our u, it is x squared. Then what is our dv dx? dv dx is 1, then divided by v squared. So our v squared there is 1, let me say our v here is x plus 1, and then I'm going to square this one. So multiplying these, what are we going to get? We're going to get 2x squared plus 2x minus x squared, then divided by, so in the down part here I have x plus 1, then squared. So as you can see, these ones, they are like terms. So 2x squared minus x squared, I'm going to get x squared, then plus 2x, then divided by x plus 1 squared. So this one is going to be our final answer. Now let's use this idea here, where you're supposed to say dy dx is going to be equal to the f prime multiplied by the g function, then minus the g prime multiplied by the f function, then divided by g of x, then we square g. Okay, so according to what we have here, our g is x plus 1 and our f is x squared. So f prime is a differentiation of that x squared. So we're finding the f prime here. So f prime is going to be 2x. Then what is our g of x? G of x is x plus 1. Then we are done for this part. The second part, what is the differentiation of g of x? G of x, we have x plus 1, which is just 1. Then what is our f of x? F of x is x squared. Then divided by g, then we square it. G of x, and then we square it. So g of x is x plus 1, then we square it. So we're going to find that when I multiply 2x throughout, we're going to get 2x squared plus 2x, then minus x squared, then divided by x plus 1, then square. So these are like terms. When I do the computation, I'm going to get x squared plus 2x, then divided by x plus 1, then we square it. So as you can see, this one and this one, they are just the same.